What are embeddings? Embeddings are just vector representations of data. Okay, sounds a little bit fancier than it is. I promise it is easy. Vectors are just numbers in an array, and that could be used for many things. But when it's used within the context of artificial intelligence, when those vectors are generated by artificial intelligence, then we call them embeddings. What artificial intelligence needs to do is query data very quickly at scale, understand things about that data. It's not just simple queries, it's semantic querying. It's understanding, for example, if something is closer to another thing. If that emoji is similar to the other emoji. I can do my fingers, right? Okay, let's try to understand that in simple terms. So let's say we have this game controller. It's a PlayStation 5 blue game controller. We want to understand all these properties about that object. And by the way, these are just 3 features of it. There are other features, right? This game controller has buttons. The buttons have colors. There's dust on it. So there's all kinds of other stuff going on here. However, we're only interested in these 3 features. So the way we're going to represent these features are by assigning numbers to them and then putting them in a vector. And this vector will have multiple numbers. In this case, it's going to have 3 numbers, 1 for each feature. Because it has 3 numbers in that array, that vector is set to have 3 dimensions. The more dimensions, the more features you can represent, the more semantics you understand about an object. Let's do the vector representation of this. I'm going to put it here, and we are going to use a process called vectorization. Behind the scenes, the way these things are done, and by these things I mean data becomes represented as vectors or embeddings, are through algorithms. They're all based on statistical analysis and statistical functions and all kinds of really brainy stuff. Now that vectors and vector databases and Gen AI has all gone mainstream, there are many different tools with this higher level of abstraction, so you don't have to worry about how these things are done. It will look at this game controller and then go, okay, this is a game controller. How can it tell? Text that you pass in, an image, a video, or an audio file, if it makes sense, like if this makes a particular noise. Once it recognizes that it is a game controller, it's gonna give it a number. So let's say it's the number 11. It doesn't have any meaning. It's just 11 because that's what the algorithm output, right? So 11 means it's a game controller. Next, it's a PlayStation 5 controller. Give it another number, say number 8, right? Great. It's blue. So we may determine that blue is number 9, and it's going to put it there on that array. This is our vector, our 3-dimensional vector. Okay, let's do another one. How about this one? Well, this is also a game controller, but it's an Xbox yellow game controller. It should recognize it's a game controller and go, oh, I know that. It's a number 11. It's an Xbox controller. Fine, I'll give it the number 3. It's the color yellow. Haven't seen that before, so I'm going to give it the number 10. Now, we have these real objects represented as numbers. Guess what happens next? Now, if we put this in a vector database, we can query to ask, what about this? What is this closest to? What is this? Okay, if you want to know what this is, let's put it into a vector. It's a game controller. It is a PlayStation 5 controller, and that's a number 8. Oh, it's white. I haven't seen that before. Okay, number 13. I don't even need that data anymore. I can put all of this aside, and I can just ask the vector database, which one is this new data coming in, which I put through the same vectorization algorithm, closest to? I guess you can tell that it will be much closer to this one than it is closer to this one. So it's gonna say, hey, these two, they are grouped. And that's how vectorization and embeddings and vector databases work. Okay, I hope that was helpful. If you want to know more about this stuff, leave it in the comments so I can make more videos about it. And please don't forget to like, subscribe, and all that kind of stuff. See you in the next one. Bye. And now, even the big ones, the big platforms have platformers. Weird, it's not Mario games. Got a magic hat. Ouch. Ding. Oh no, it's right at the bottom. Right? Number. Okay, the magic hat was a bad idea.